It would be nice to add some power-ups to the game, such as a better turret, faster movement, etc. For this we are going to use buffs. Buffs are simple objects that contain some buff logic. All buffs are managed by the buff component. Let's start with player buff. It's a simple U object that is marked as abstract, blueprintable, and blueprint type. Then under public section I have three core functions: init, tick, and deinit. Then I have a couple of blueprint callable functions for getting and setting values. Then under protected section I have three blueprint native events: onInit, onTick, and onDeinit. We're gonna override those functions for setting some custom logic for different buffs. Then I have starting duration and the visual data. Visual data is another simple struct that has buff icon and gauge color. That's it. Then I have implementation for blueprint native events, and finally under private section I have some couple of configuration variables. CPP file is not very complicated. First of all, I have an include for asteroid game pawn, then inside init function I check if a valid player was passed, and if it was, then I do some basic initialization, then I call on init. Inside tick I check if we can tick, then I decrement current duration, and I check if current duration less or equals 0, I set expire to true. And we call on tick only if we not expired. Then inside deinit I simply call on deinit. Then I have a simple implementation for getter and setter functions. And inside onInit implementation I simply add comment that it's a default implementation. Let's take a look at player buff component. First of all, I have two forward declarations and three delegates. And first one is actually simple delegate and not multicast delegate. And the reason behind this is that we're gonna use this as setup delegate and not as event listeners. Then I have our player buff component. This is an actor component, and I also marked it with meta tag blueprint spawnable component, so you can add this component inside blueprint. Then under public section I have a constructor, on buff added and on buff remove delegates, then tick component function, and two functions for adding buffs. First one is for blueprint usage. Here I pass T subclass of player buff and this delegate, pre-init delegate, and I'm gonna show you the usage of this very soon. Then I have another add buff by class. This function is for internal or C++ usage. Here I also pass a buff class, but this time I use const t function instead of delegate because we're gonna use lambdas in C++. And then I have a function for removing buff, begin play, and some internal variables for managing buff logic. Inside CPP file I have two includes, one for asteroid game pawn and another one for player buff. Inside the constructor I simply set can ever tick to true. Inside begin play I try to cast an owner to asteroid game pawn. Then I ensure that we have a valid owner. Inside tick component function we can only tick if we have a valid owner. Then I iterate over all player buffs, check call tick inside buff, then I check if this buff is expired, and if it's expired I call remove buff function. This function simply checks if it's a valid buff, then it calls deinit and adds this buff to pending removal buffs and broadcasts the delegate. And the reason it was made like this because we don't really want to modify an array while we iterating over it. And once we are done iterating, I delete all buffs that were moved to pending removal buffs. Then I do the similar logic for pending add buffs because we only want to add new buff at the end of the component function. Then we can speak about add buff function. Let's start with add buff by class. First of all, I check if we have a valid class, then I try to create an object based on this class, and if we can create this object, I check if we have a valid pre-init lambda. If we have a valid one, it tries to broadcast itself using this created buff as a parameter. Then I add this buff inside pending add buffs. Then I simply call on buff added delegate and return this buff. So this add buff BP functions simply calls this add buff by class function with custom lambda where we execute this blueprint delegate. And that's it. We are ready to use player buff component inside our Asteroid game pawn. This is not gonna be something new for you because we did a very similar thing with player health component. So here I have a forward declaration for player buff component, a public getter function for this, and t object pointer for this as well. Inside CPP file I create player buff component using create default subobject, and then I simply return it inside get player buff component function. Before we can continue, I would like to show you a small thing I've added to BP asteroid movement component. Inside event tick, I check if owner actor is valid, then I do the rest of our logic. Let's create a testing buff right now. For this, navigate to blueprints folder and create a new folder called buffs. Inside this folder, let's create a blueprint class from our player buff and call it BP test buff. Open this file and override on init and on the init functions. Here we can simply type print string and connect hello to on init and bye to on the init. Now let's add this testing buff to our player. For this, open bp underscore player and type input in search and select auto receive input to player 0 so we can use key events. Now type key and select 0 here. Now we can press 0 in game and this event will be fired. Now take our buff component and type add buff. Now we can select our BP test buff and press compile. Actually, we forgot to do one thing. For this, we don't always wanna have to make a custom event if we don't have additional setup. And as you can see right now, we have to do it, otherwise we see an error. And to fix this problem, we can use another interesting meta tag inside Unreal Engine. For this, simply type meta and select auto create ref term and give it name of our pre-init delegate. Now we can rebuild our project and this error should be gone. Let's test it. Now when we open player blueprint, we no longer see this error. Nice. Now let's try to play and press 0. And as you can see, hello message was printed and after 10 seconds we should see bye message. Let's wait for this. Yes, and as you can see, bye message was printed as well. Great, everything seems to be working just fine. Now let's talk about this pre-init delegate. This is a convenient way of setuping our buffs. We can drag it and type custom event and give it some setup, for example. And now when our buff will be added, this function will be called. So we can simply drag this and, for example, call set duration. And instead of 10 seconds, let's set to maybe 3 seconds. And now bye message will be printed much faster. Now we press 0, we see hello, and after 3 seconds we should see bye. And as you can see, we see bye, and that's the whole power of this setup and delegates. Let's talk about player buff material right now. As you can see here, I prepared a simple material, and the whole idea of this material is that we're gonna use this gauge percent value for representing the player buff's duration. So we can set it, for example, to 0.5, and now it will be half filled. And this is actually a user interface material with translucent blend mode. First of all, I'm having this radial value mask. I use texture coordinate and connect them to custom rotator with 0.25 rotation angle. This rotation angle just clarifies that this radial progress bar will be in clockwise order. So if we type 4 here, as you can see, it was filled a bit more clockwise. Then I subtract 0.5 and I actually expanded it so you can see the preview of texture coordinate and what happened to them. Then I multiply it by x1 and y minus 1 and connect this to vector to radial value. And as you can see here, it produces this rectangular gradient. And the more percentage we have here, the more apparent they will be on the right side, on the field side. So then I connect it to the floor and floor produces the mask we need. Now let's revert it back. And as you can see, I connect this floor result output to radial mask. This radial mask is actually a named reroute node. You can click on this and give it some name. Now when you connect something to it, it will output the same result. So in different places you can type give some name and use it like I did radial mask. So it's a convenient way of managing your material nodes. So as you can see, I'm using this radial mask here. Now we can take a look at material setup. Here I have two radial masks, one for creating this gauge region and another one for creating this region for the image. Here I'm using the same radius, but from second radial mask I subtract thickness. So this basically removes this gauge from this part. And here I'm using a simple texture parameter, but I center it slightly. So as you can see, this cuts these places and now it looks centered as we expected. Then I connect this gauge mask to multiply node and multiply it with our square gradient. So it basically makes the result we want. So when we increase it to 0.5, you will be able to see that it was updated. And we also multiply the result with a color. So we can change it to something like pink and you will be able to see that it's updated. And also here we combine two opacities because in our final image we need opacity from this mask from our texture and opacity from our gauge. And we connect this to opacity. And finally, we are doing lerp based on field circle mask. So any pixel that inside this region will get pixels from this icon. And any pixel that's inside this gauge region will use gauge. And we connect this to our final color. And that's basically it. We are ready to make widgets for player buffs. It's gonna be very similar to how we created our hearts. So let's create another widget, select user widget and call it BP player buff. This widget will have only image and set it to desired so it has a nice preview. Now select here our material. And now we should be able to see it like this and set the size to something maybe 50. Yeah, 50 should be about right. And now it's a good time to show you why we used opacity here. So if we disconnect this and save, we'll see corners as black textures and we don't really want it. So that's the main reason we use this opacity. So when we have it, this looks as we need it. Now we can leave it for now and now we're gonna use this inside player widget blueprint. And actually I also realized that we can add small improvement. Remember how when we were doing player widget, we added field player health box and inside it we clear children inside our health box. That actually means we can add here some previews. So let's do it. So we can drop it here and duplicate it. But maybe we actually need to set a padding. Right to 5. Let's check this. What is default padding? Default one is 10. Okay, let's set it to 10. and duplicate it. Okay, now it looks, why it didn't set here? Because it should be less padding, yeah. Okay, looks about right, and now we can even add fourth, because when we press play, everything will be correctly displayed as 3, because this value comes from the code. And these values are simple preview. Okay, now let's think about how we would like to see our buffs. I would like to see them above our health. For this, we need to wrap this horizontal box with vertical box. And now we can duplicate it. And yeah, as you can see, it looks as I expected, but now we need to move it here and rename it to player buffs box. Now we can remove those previews and use our newly created player buff. We can use the same padding here for 10. Maybe it would be good to set the same size. Okay, let's test it. And the size of image was 64 if I'm not mistaken, right? And let's use 64 here as well. Okay, this looks a bit better. So I guess we can save it. And I would also like to have some bottom padding here, maybe also to 10. Yeah, looks great. Now we can set up the code for this. First of all, we need to mark is variable for our player buffs box. Inside graph, I have two events, construct and destruct. Inside construct, I get player pawn, then I cast it to bp underscore player, and I check if it's valid, then I get player buff component and set it to our variable. Then I check if it's valid, and if it's valid, I take player buffs box and clear children, similar to what we did in code for hearts, horizontal box. Then I take this player buff component and get this bind event on player on buff added and on buff removed. Here you can drag this and type create event to make this stuff. Inside destruct, I check if player buff component is valid and I do very similar thing, but this time I unbind event from. Then here I selected create a matching event, and this created this one and this created this one. Now we are ready to populate everything. First of all, let's actually add a variable inside our player buff because we want to set up the material. So for this we need to make one variable called player buff, and type should be player buff. And this should actually be public and should be exposed on Spawn, not instance editable. Okay, now when we have it, actually it should be also instance editable. Okay, great. Now when we create a widget here and we select player buff, we'll be able to send buff, so we can do it like this. That's why we expose it. And now inside player buff we need event construct. Oops. Yeah, this one. And we actually need to mark our buff image as variable as well. Okay, now we can use it. Now drag it. And we actually only wanna do this if we have a valid player buff. Okay, great. Now we can create dynamic get dynamic material, yes, this one. And now this node will automatically try to create a dynamic material based on this image material. Now, if we have a valid dynamic material, we would like to store it as a variable. and call it dynamic buff image. Now we can use sequence node. First of all, we would like to set gauge color and this icon. So take our dynamic material and take player buff. Here we can get visual data and split it. And if we have a valid icon, we can set texture parameter. And this icon is called icon, yeah. Then we would like to set vector parameter for our color. And this one is called gauge color, yeah. Okay, great, we have a basic setup. On player buff added looks like this. I get owning player, then I create a widget blueprint for our player buff, and then I add this to player buff. And one small changes, I also clear this player buffs inside event construct here. Then I take player buffs box and add child to horizontal box and set padding to right. So inside player buff removed, I use for each with break for each player buffs, and I check that this widget has the same buff that was removed here. So if that's the case, I set found buff and I call break here. And on completed, I check if found buff is valid, and if it's valid, I remove this from player buffs, then I remove this from parent, so this node will actually automatically delete this from horizontal box because his parent is a horizontal box, and then I set it to null, yeah. And that's the whole logic we need for player widget. We forgot to update gauge percent inside widget blueprint player buff. So here I have an event tick, and first of all I have this big end statement. I simply check if player buff is valid, then that starting duration is bigger than 0 because we don't really want to divide by 0 here, and then I check if we have a valid dynamic buff image. Then if that's the case, I set scalar parameter value for percent, this percent I mean, to current duration divided by starting duration. And that's it. Now when we open player, not player controller, player, we have this node here. So when we press 0, we should see our buff, and indeed we see it, and it has a nice percent duration displayed. So yeah, I guess it looks pretty good. We can even test it and add lots of buffs, and they will be automatically moved to the left position when someone is expired. So great. Now I can show you another how we can modify this visual data. So if we take visual data here, you can set visual data and you can make it. Connect here and connect this one here. So for example, let's select gauge color to yellow, and for buff icon, let's select this AI spawn point. Now when we press 0, we see a yellow gauge and a new icon, and that's how flexible our new buff system is. In the next video, we're gonna add some real player buffs.